Our system is based on the Deming model, the Plan, Do, Check, Act model. We have energy goals. Some of you are probably aware, because you're connected with the Labs 21 population, that we have a goal of becoming carbon neutral. That goal was 2050. The Faculty Senate has now decided that we are to become carbon neutral by 2035. So we have a little bit less time, but I think we can still do it. Our ventilation program is tied to a Green Labs program that is taking off. This is also energy driven. So in the planning stages of these programs, the goal is to reduce the energy that the labs use. But in the process of doing that, we have to keep people safe. Part of our program is to periodically check, and this is always happening. It's not something that happens once a year. To check to see how the program is doing, and then to tweak the program to make sure that everybody's staying safe, that there are improvements in the program, and that it ties back into the planning stage, that we have this balance between energy and safety. The key indicators that I mentioned, Ralph and I are systems people. This tends to get lost in people that don't understand management systems, but these things are very important. And when you have some sort of management of your ventilation systems, there's a design process, there's some sort of maintenance, there's some sort of decommissioning. When you tie those into a management system, you're checking to see how those things are functioning together so that the program itself is monitored and can improve different components of the program. So a leading indicator is something that is driving a change in the program, or it's driving change of activities. A lagging indicator is something that is monitoring what is happening to see if the program is functioning, that those changes that you're making are actually working for the program. And conveniently, how we set it up, we have 2 leading, 2 lagging. There's 2 sustainability indicators, and there's 2 safety, and they seem to fall right into place for us. The 2 that are purple that you see on your screen are the ones that are very important, that in the first year of this program have advanced the fastest. And I'm going to speak to those because there's something that's brand new. The other 2 is something that I'm working on this year, because looking for the improvement in safety observations, audits, our EHS inspections, IAQ concerns, the amount of hazmat responses is something I need other people in my department to develop that with me so I can monitor those on a regular basis. But this year, just so I can have some track of the program that's outside of Cornell. We have others that are tracking the energy conservation projects, but the program as a whole, we need to know just how much energy we're reducing because of this program. So let me go on to talk about these other 2 that are brand new, that are unique to us, but we're very proud of them. The Hood Housekeeping Score is designed to capture information about fume hoods that are being used in the lab, and I'll go into detail on that. And then the control banding I've spoken to at a couple of places. This is a sorting of the labs based on the chemical hazards associated with the work that's being used in the lab. And this is tying into the Green Labs program that I mentioned, and also our inspection program. The Good Housekeeping Score has 5 levels. It is based on increasing severity, but it's actually separated into two portions. When we go to look at a hood and we see one that's empty, it's full of boxes, it's just being used for storage, This is a sustainability concern because we have active decommissioning, temporary decommissioning of fume hoods. We call it hibernation. So we want to be able to go back. We want to identify what these hoods are and then go back and have them turned off, even if for 3 months it saves energy. And then the other two concerns that are at the top, a hood that is crowded, that appears to have competing multiple chemical uses, and a competing chemical uses can end up in accidents where people are injured. If you have a fire and there's something that is also flammable that's just sort of forgotten about in the back of the hood and that lights on fire, that's a hood that has a competing chemical use. A hood that is on that has contamination, that is a concern because that could not only damage the fume hood itself, but also the ductwork and the valve, and that ends up costing money. Those folks that's a lab, a fume hood use issue that needs to be taken back to the lab folks that are using that space, and a conversation needs to happen with them. And then hopefully that the next time that hood is scored, it'll be a 2, and forevermore would be a 2. The other key component, the energy conservation component of the program, is the control banding. This is a generic protection strategy that groups similar hazards into bands. We have 2. I'll describe them briefly. It is based on which chemicals are used and how they are used, where they are used, how they are stored. I can go in to band a lab, and if there is poor management of the chemicals and there's students that have their little sections of their chemicals, they're purchasing their own. This is a culture problem on the safety side. I can go in and have a conversation with the PI, with the group safety reps, with the department safety reps, and we can begin to change that culture. This is a piece that ties directly into green labs. And then, if we change the culture, we have better use of these chemicals. What was a lab that needed higher ventilation rates, maybe I can reduce the ventilation rates. And sometimes this is a process. Sometimes it's a one visit to talk to folks, and then they fix it, and then I can make the recommendation to lower the ventilation rate. Sometimes it's a much more in-depth process. This is rooted in CFD modeling, which has been included in our design standard. Our approach to operating general ventilation rate starts with 8 air exchanges per hour occupied or unoccupied as minimum ACH rates. Then we look for opportunities to go to 6 and 3 when the chemistry permits. And conveniently, a 6 and 3 lab, if we are in the design process and they're having trouble sizing an air handler, if we can come in and we talk with the researcher that's moving into the space, we have a chemical inventory, maybe we can make a recommendation for 6 and 3 where the chemistry permits, and then go back and look at how the lab is being used after it's been renovated. And we only try to do this if they're having trouble sizing an air handler. Typically, we need to go 8 and 4 as the baseline. But sometimes we can have that conversation with the design folks and with the folks that are going to be using these spaces to give us a little bit of wiggle room. What we're seeing is that in a heavy chemistry building, like in our chemistry department and our chemical engineering building, most labs might be 8 and 4, but there will be ones that are 6 and 3. So, and we need to be able to go back and reband these labs every so often, which is every couple of years. And some of them, that the use is going to change. The practices are going to change. And so different labs might be 8 and 4, and different labs might be 6 and 3. But this gives us a little bit of wiggle room in the design process, in the design time, and it's actually come in handy. 6 and 3 to the happiness of our mechanical engineering group here is actually slightly above the 1 CFM per cubic foot. Some other campuses are going much lower, they're more aggressive, and we have decided to take a more conservative approach because we are working jointly with these other folks in designing these spaces and operating them. Sometimes, unfortunately, we have spaces that need that the labs are small. They have lots of heat generating equipment like ovens, biosafety cabinets. They have need for more than one fume hood or a large fume hood, and these target rates are overridden by exhausted temperature requirements. That's just part of the game, but we are finding that this control banding process is working. It is working. We do have spaces that it doesn't work, but we recognize that, and then we go to the other spaces. So it is a 3-step process. I'm not going to go into great detail, but as I said, we start with 8 and 4. We look at the chemistry. We look at ventilation effectiveness that we put into our design standard, and then I'm a former lab manager, so I'm always looking at housekeeping. The last step is housekeeping and basically the management of the space. A messy space that isn't control needs to improve their practice in the lab, and then they can go down to 3 as well. But sometimes that's a stop and